Good morning, students. As now we are going to solve few numericals. Numericals are already written on the board. So let us solve first numericals. Okay. Determine the electrostatic potential energy of a system of two charges 7 microcoulomb and -2 microcoulomb placed at 9, 0, 0, 9, 0, 0. Here is minus and here is plus. So when the charges will be placed here, suppose this is the x coordinate, y coordinate, z, and this is x, y and z. So you can see y and z coordinate, nothing is getting here. Only on the x coordinate the charges are held. And one is on -9, another is on +9. So total distance will be 9 plus 9, 18 centimeter between the charges. So this is what I have written. Q1 is 7 microcoulomb. Okay, micro to coulomb 10 power minus 6. Q2 is given to us -2 into 10 power minus 6 coulomb, and already we have calculated the distance 9 plus 9, 18 centimeter, that is 0.18 meter if we have to convert into standard unit. Now students, electrostatic potential energy for a system of charge, we already have studied the formula. So U is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R. Now substitute the values. 1 upon 4 pi epsilon naught, 9 into 10 power 9, Q1 value 7 into 10 power minus 6, Q2 is -2 into 10 power minus 6, then divided by R. Distance is 0.18. Now let us solve this and you will get -0.7 joule. So this is the potential energy for the system. Now students, in the B part they are asking how much work is required to separate the charges. Okay, so what is the potential energy? -0.7. Same will be required to separate out the charges, okay, to bring it. So that is why the work done will be equal to the potential energy. So 0.7 joule is the work done. Now C part, suppose the same system of charges is now placed in an external field E is equal to A1 upon R square. A is given to us, okay, and then we have to solve it further. So energy of two charges in external field, we already know it. We have to calculate the energy of interaction of two charges plus the external mutual internal energy of two charges. Okay, we have done one derivation on the similar basis. So that is why we have done this. So Q1 VR1 plus Q2 VR2 plus this mutual interaction energy. Now students, what is the value for potential? Potential V is equal to ER. Now substitute this value. VR1 is equal to ER1. Similarly, VR2 is equal to ER2. That's why you can see one R2 is multiplied here. Similarly, one R1 is multiplied here. And this value already we have calculated, that was -0.7. So we can directly substitute this. Now substitute the value of ER1. ER1 is given to you. E is equal to A1 upon R square. So substitute the value of E1. If E is equal to A1 upon R square, so E1 is equal to A1 upon R1 square. E2 is equal to A1 upon R2 square. So in the similar way we have substituted the value here. So in place of ER1 we have substituted A1 upon R1 square. Similarly A1 upon R2 square. Now one R1 is in numerator, one in denominator, gets cancelled out. Similarly here as well. Now let us substitute the value of Q1 A R1. Q1 value is given to us, A value is given to us. What is the value of A? 9 into 10 power 9 divided by R1. So when you will solve this whole term, you will get 70. And when you will solve this whole term, you will get -20. And -0.7 already we have calculated. Now just solve it and simplify it. You will get 49.3 joule. This is going to be the answer. I hope you understood this. Now students, let us solve the further numericals. So second numerical is three charges minus q plus q and minus q are placed at equal distances. Firstly visualize the figure. Okay, so one charge is how much? Minus q, another charge plus q, and third charge minus q. Okay, are on equal distances. Consider this distance r, so this will also be r, and total distance will be r plus r, that is 2r. So this is the distance three charges are separated on straight line if potential energy of the system of three charges is 0. So total potential energy is given to us. What will be the potential energy? U1, U2, U3. Now let us calculate the potential energy. U2 minus Q and plus Q. What will be the potential energy? But we can do 1 upon 4 pi epsilon naught, we can take common because we will get in all the terms. Okay. Now what will be the value of U1 because of minus Q and plus Q? So that will be minus Q divided by R plus what will be U2 means because of Q and minus Q. So that will be plus Q into minus Q divided by distance is R. Now what will be the third potential energy? Because of minus Q and minus Q. So that will be minus Q divided by distance is how much? 2R. So this is the total potential energy and this is given to us. That is already 0. So now students 1 upon 4 pi epsilon naught on another side of 0. This will become 0. So we will get minus QQ upon R minus QQ upon R. Okay. Then minus Q square upon 2R is actually equal to 0. Now let us take the LCM. 2R will be the LCM, or what else we can do, we can simplify this. So we will get after adding these two minus 2QQ upon R minus Q square upon 2R is equal to 0. What else we can do? Q upon R we can consider common. So after Q upon R taking common we will get minus 2Q and then minus how much we will get? Minus QQ already we have taken common, and one thing which we have to correct, minus Q into minus Q, this will be plus Q. So this is plus term. So Q upon R already we have taken common. 1Q divided by 2 will remain here is equal to 0. This will go on the other side of 0. So Q upon 2 is equal to 2Q. So what will be the value of Q upon Q? So Q upon Q will be how much? 1 upon 2 is already there. Okay. And this 2 will also go in divide. So Q upon Q is equal to 1 upon 4. So Q ratio Q is equal to 1 ratio 4. This is what we had to calculate, the ratio Q by Q. I hope you understood this numerical. Now solve the last numerical of this lecture. Third numerical. An electric dipole of length 2 cm is placed with its axis making an angle 60 degree to a uniform field of 10 power 5 Newton per coulomb. Firstly visualize this figure. So let us draw the uniform electric field. So uniform electric field is in this direction. Okay. And what is the magnitude of the electric field? That was given to us. An electric dipole of length 2 cm is placed with its axis angle of 60 degree to a uniform electric field of 10 power 5. So this electric field is given to us 10 power 5 Newton per coulomb. And electric dipole is making an angle 60 degree. Okay, fine. So this is how we have drawn one dipole and say this is the electric field direction and the angle of dipole with the electric field is how much? 60 degree. Okay, fine. It experiences a torque 8√3 Newton meter. So what is given to us? Tau is given to us 8√3 Newton meter. What else is given to us? The length of the dipole. So length of dipole is always taken 2a. So 2a is given to us 2 cm. Fine. Anything else is given to us? It experiences a torque. Okay, electric field value is given to us already. So E is equal to 10 power 5 Newton per coulomb. Now students, these are the values given to us. So what is the formula for torque? Torque formula is tau is equal to PE sine theta. If we use this formula, so what is the value of tau? 8√3 is equal to P. What is the formula for P? P is equal to Q into 2A. Dipole moment is given by the charge, either charge into the distance between the charges. So Q into 2A into electric field E sin theta. Now substitute all the values. 8√3 is equal to हो जाएगा Q. What is the value of Q? Not known to us. Into 2A is given to us 2 centimeter. So that will be 0.02 meter into E sin theta. What is the value of E? 10 power 5. And what is sin theta? So sin 60. solve it further. 8 root 3 is equal to q into 0.02 into 10 power 5 into what is the value of sine 60? Root 3 by 2. So what will be the value of q? Q is equal to 8 root 3. 2 is in divide, shifted there, becomes multiply. So 2, okay, fine, divided by 0.02 into 10 power 5 into root 3. So root 3 and root 3 gets cancelled out. Point and then 2 zeros we will erase. So q is equal to 200 into, okay fine, so 200 is here, 2 1s are 2, so we will get 100 and 8 is remaining into 10 power 2 and plus 5 shifted there becomes minus 5. This is 100 is 10 power 2, so 10 power 2 minus 5, so this will become 8 into 10 power minus 3 and this we can write as 8, okay, for this minus 3 we can write milli, so 8 millicoulomb or 8 into 10 power minus 3 coulomb. I hope you understood this. Then potential energy of dipole. What is the formula for potential energy? Potential energy of dipole is given by PE cos theta. Okay. So by substituting the values you can calculate, or I can write it for you so that you don't have to solve it further, and I can check it out the answers as well. Okay, the first answer is correct. And potential energy U is equal to PE cos theta, and when you will substitute all the values, here is minus also if you remember, so this will be equal to minus 8 joules. So this is the potential energy of the system. I hope you understood all these numericals. Thank you. God bless you.